Welcome to solverfy.
This is chapter 27, problem number 76. We are using a model to determine the total magnetic moment of a neutron. Even though it has zero net charge, it does not have zero magnetic moment due to the individual moments of the quarks that the neutron is consisting of. So in part A, we are asked to determine the current due to the circulation of a U quark. So in order to figure this out, as you know, the current is going to be Q over T, T being the period for one revolution. Q for a U quark is 2 plus 2e over 3. Then remember T is 2 pi r over v. Then plugging it in here, 2e over 3 times 2 pi r over b. Then we have 2's canceling, ev over 3 pi r as the current of an up quark. Now in part B, we were asked to calculate the magnetic moment due to this current of an up quark. So mu is going to be IU times the area being pi r squared. So substituting for IU, the current of a U quark, EV over 3 pi r times pi r squared. Pi's are going to cancel, r's are going to cancel. EVR over 3 is going to be our magnetic moment for an up quark. In part C, though, let's separate this part. In part C, we're asked to calculate the total magnetic moment of the system, since we have 2 down quarks and 1 up quark. Mu down plus mu up is going to give us the total magnetic moment of the system, which means we need to figure out what the magnetic moment is of a down quark using pretty much the same logic that we used in part A. First, we can calculate I down, which is Q over T, which I'm calculating the magnitude, E over 3T. Then substituting for T is going to be EV over 3 times 2 pi r, which is EV over 6 pi r. This is just a current. Now, in order to get to the magnetic moment, we have to multiply it with the area, right? So EV 6 pi r squared. R's are going to cancel, pi's are going to cancel. For the magnetic moment of the down quark, we're going to have EVR over 6. So then mu total is going to be equal to EVR over 6 plus EVR over 6 from this equation that we established, plus EVR over 3. Okay, so then the answer would be 2 EVR over 3 as the total magnetic moment of the system. Now in part D, we were asked what the speed is for the quarks according to this model, given r equals 1.2 times 10 to the power negative 15, and also mu total was given to us initially as 9.66 times 10 to the power negative 27 ampere meter squared. As we know, this basically equals to 2 EVR over 3 that we just calculated a second ago. So then let's isolate V out of this equation. So then V is going to be 3 mu total over 2 ER. Then 3 times 9.66 times 10 to the power negative 27 divided by 2, E being 1.6 times 10 to the power negative 19 coulombs, times the radius that is given to us, 1.2 times 10 to the power negative 15. Then the final answer that we have for the speed of the quarks is 7.55 times 10 to the power of 7 meters per second.